This project is basically comparative analysis of XOR-XOR based 18 transistor full adder cell. Basically, this project is developed for the full adder circuit based on CMOS using the LTspice model, and I have used the XOR-XOR architecture provides the important impacts design strategies which can be optimized further. Okay. So in which I need to use ALU, DSP blocks and the inputs and outputs based on the sums to calculation for the sums and the carry of the CMOS logic. Okay. After that, the circuit design. In the circuit design, we must need to consider 18 transistor full adder uses a combination of two XOR gates followed by the logic elements to carry generation. So in the full adder design, I have to use the NAND, NOR, and inverter logic structures using the complementary arrangements of PMOS and NMOS in the LTspice. Okay, in the simulation setup, we need to calculate the sum with the propagation delay, average power consumption, and overall simulation time. Because the main purpose is the simulation time is most important. The input is 16 input combinations and we have used XOR-XOR design components. FGT cells which are not essential at the first stage, but these are the used in our cases as well. So these are the block diagram for used for state 1, state 2, state 3 and state 4. These are the time delay and the voltage levels accordingly the different stages of FTG cell. And next part is the simulation of FTG cell. Basically these cells are defined the read and write the memory and input and the output results of the overall LTspice full adder circuit. Okay. Basically, this also presents the battery development circuit. I have also included the different levels of battery voltages based on input and output results. Okay, see this graph represents the reference voltage, its input milliampere current, and the output voltages as well. Yes, this figure represents the simulation environment of the created macro cell, basically FTG cell. Okay, next part is basically yes, this one presents the current voltages of reset and the buttons. Basically this presents the button switching buttons properties. Yes, this table also presents the circuit, 4-digit circuit and its different stages. Like this table represents the digital logic tables of full adder based on this circuit. Okay, these are the different stages like first stage, stage 2, stage 3 and stage 4. Then state set 1, 2, 3, 4 and 5. Then 4. Okay, and then FTG cell 1, 2, 3, 4 and the same case interface of FTG 1, 2, 3 and 4. Okay, and then finally we just present the output with the capacitors, because capacitor also used to remove the noise, and then voltage used as a write of the signal. Okay, and this is the digital logic circuit to determine step 1 of the ternary adder. Okay, yes, these are all the circuit steps used in the LTspice to design the full adder circuit. Yes, this one is a table used for the states and different output results based on different conditions. Okay, yes, this one is basically the complete circuit for the FTG cells, like how it behaves. Yes, this circuit also presents a feedback loop in the memory compute operation. Okay, after that we just need yes, we have added the diagram for simulation of schematic shown in figure 10. Okay, and next part is basically this is the final circuit of complete circuit diagram, ternary 4-digit addition, which also the memory compute operations added in it. Okay, so yes, these are the different states switches. Okay, yes, this is the final full adder circuit for the LTspice circuit, in which we need, have added some carry. This is a carry output. Okay, using the XOR-XOR to XOR-XOR in series, connected in series to present the sum and carry. Yes, this one is the output graph of sum. This is the output graph of carry in the LTspice model. Okay, yes, this one also presents in it the FTG's complete circuit in LTspice, the output results. Okay, conclusion. Let me just also show you now the circuit, different circuits. First one, we need to just open this full adder circuit. Let me just show you the full adder circuit for you. Yes, this one. Let me just run this circuit. We just need to check the sum. This one is the sum. This one is the carry. Okay. Let me just also show you the next part is total circuit for the FTG cell. This is the cast circuit. Basically, I have just added all the circuits separately. When we just run this circuit, like for example here, this one is the output, this one is the output, this one is the output, this one, and this one. See, all the output presents in it. Let me just also show you the total F circuit with the FTG circuits. Yes, this one. For example, we just run this circuit as well. We got these different steps as well. Okay. So these are the complete circuit. I think it is okay now.